This is Physics 2212, Lab 2 by Nicholas Schweiker. So principles and purpose, this lab expands on the last lab where we are trying to get a more accurate value of the amount of charge on a single piece of the charge tapes. I use a model of a large number of small point charges rather than a single point charge. The preview of the results is that I got the entire charge of the tape is 2.5 times 10 to the negative 8th coulombs. Some important physics concepts are Newton's second law, F equals ma, where gravity is 9.8 meters per second squared. There's Coulomb's law, where the electric force is k times both the charges divided by the distance squared. Electric field, which is just E equals kx, and electric force, which is just F equals qe. And then there's charge of the electron value. Assumptions, we are no longer assuming that the tapes are point charges. We're assuming that it's distributed charge. And by assuming that, and then we're also assuming that both the pieces of tape have the same charge. We're also assuming that air resistance is negligible. Here, we just have some visual diagrams. In the upper right, you have the strategy used to get the two different charge tapes. And then in figure 3 in the bottom right, you have your hand just to show that, like, because your hand is neutral and then the tape is either positive or negative. That just shows that the tape is charged by the fact that it's being attracted to your hand by polarizing. And then the bottom left image, that is just the setup for the experiment. So for the experimental setup, the system versus surroundings, the system is both of the pieces of tape, A and B, and the surroundings is Earth exerting gravity on the pieces of tape. Initial conditions are there will be two pieces of tape fastened to a countertop while another piece of tape with a handle is stuck on top of each of the first two. The tapes with the handles are 20 centimeters long. Other procedures. Now that the charge tapes are separated, one will be secured over the top of the tables, then the other piece of tape will be moved right underneath until it becomes suspended above the tables, pretty much floating. Now we measure the distance between the two tapes. So here we have the glow script code. I'm not going to go through all of it because that would take too long, but if you want to, you can go through all the code to the right. And then here we continue the glow script code. Once again, you can go through it if you would like. So you see the two pieces of tape, and then you can see the white arrow is the net electric field with all the green arrows being summed together. Those are supposed to be like breaking them into point charges, like many very small point charges. And then the yellow arrow is gravity. As you can see, those two are the same magnitude, which represent how net force is equal to 0, and how they're in opposite directions. And then plugging in values, I found a Q value of 2.5 times 10 to the negative 8th coulombs. That value is 2.3 times bigger than last lab's calculations. So for the conclusion, differences between the model and reality. Still, the charges are not actually evenly distributed, so a perfect model in GlowScript to depict this situation is near impossible. Also, the charges on the tape are not of equal value, so at one point you might have 5e, and at another you might only have 2e, so it kind of varies. Potential sources of error is, of course, these differences between charges and unequal distribution. There also might be some electrostatic attraction between the air and the tape that's not taken into account, or just air resistance. Handling pieces of tape likely lost some charge, decreasing dead accuracy. Then also tape likely just lost some charge as more time goes on due to the air. What if we model the tapes as a single point charge? By modeling the tapes as a point, it ignores how the non-vertical electric force component from the edge of a piece of the tape to a different spot on the other piece of tape. This makes the estimates in the point charge data lower than what they actually are because the horizontal components in this lab's model cancels out. Why do these estimates differ? Which one is closer? These estimates differ because there are X components, like I just said, in this lab's model that cancel out, causing there to be stronger charges, as they need to be stronger than if they were just point charges. The data in the second lab is much closer to reality because the charge is closer to being evenly distributed on tape than it is in just a point.